Welcome to another Mr. Paul video. In today's video, we're talking about transformation basics. Now, in the next three videos, we're going to be talking about the different types of transformations. But for today, we're just talking about transformations in general because I feel the hardest part about the geometry is the talking about the specific things that have different names from what we say versus what math says. So in this video, we're going to be focusing strictly on how we can translate what we are trying to say into what math would say when talking about geometric shapes and how they move. And that's how we're going to get today's video started. So what exactly is a transformation? Well, in geometry, when an object or shape moves, okay? Meaning, let's just say I have an object, okay? In this case, I have a square. This is also a shape, right? If it moves, such as like this, okay? This is a type of movement, and like this. We're talking about how it moves. In math, they call this a transformation. Transformation. Kind of like a transformer. You know, like Transformers, Michael Bay films. Now, let's just talk about this shape. This is a square. This is my square. It's just an index card that I've outlined with highlighters so that you can see it easier. Now, if I was to ask you, how would you make this move? Well, you might say, well, what do you mean? Well, okay, I mean, could it move to the left? Could it move to the right? Could it move up? Or could it move down? Okay, that is a type of movement. It could move, I don't know, in this direction. It could move in this direction. I suppose it could move like this. Okay. So there's lots of different ways to make this move. Now, for this video, we're not talking about what would happen if I folded it in half or I crumpled it into a circle and then threw it on the other side of the monitor. But we're going to talk about movement that keeps it the same size, okay? So let's focus on the movement that first takes it left, takes it right. Okay, in this video, we're going to call it sliding left, sliding right. And we're going to say that it would slide up or slide down, okay? To kind of illustrate that the shape is starting somewhere and then it's moving or sliding to the left or to right or up or down, okay? So this type of movement is one of three types that we're going to learn. So when we say a shape slides, okay, we say that the shape would slide. Math calls this a translation. A translation. So when we were looking at our object and we were saying that it slid up, slid down, slid left, slid right, math calls this a translation, okay? To translate is to slide, basically. So this is translate up, translate down, translate right, translate left, okay? This was the first type of movement we described. The second type of movement we described was, what if it moved like this? Or what if it moved like this? If we were to put our word to it, we would say this kind of turns. In this case, it turns the way that a clock would turn. So they call this clockwise. So if like this was the hand of a clock, it would be going around the clock from 6, 7, 8, 9, 10, 11, 12, 1, and continue on. They call this clockwise. This would be a clockwise turn. And if it's going the opposite direction, meaning opposite the way a clock goes, it's called counterclockwise. These are two directions to turn the card. Okay? Now we're going to describe that movement. Number 2. When we say a shape turns, math calls this a rotation. Okay? Math calls this type of movement a rotation. So for example, when we had turn clockwise, math calls this type of movement rotating clockwise, to rotate clockwise. When we were turning opposite the way the clock goes, meaning turn counterclockwise, math was calling this rotate counterclockwise. Okay? The last type of movement that we had was when we took our shape, in this case the square, and what if we were to flip it over? Okay? We would call this flipping it. Okay? We could flip it to where the top becomes the bottom, meaning I flipped it over like this, or I could flip it sideways. Or I can think of it as if there was a horizontal line right here where my fingers are connecting, and if I was to flip it along that line, flip it along a horizontal line, or if there was a line that went straight up and down called a vertical line, this would be flipping it along the vertical line. Okay? This is the type of movement we're going to describe next. When we say a shape flips, math calls this a reflection. Math calls this a reflection. Okay? So when we had our shape and we were saying that this was flipping along the horizontal line, and this was flipping along the vertical line, math calls this a reflection horizontally, meaning along the horizontal line. This is a horizontal reflection. This is a vertical reflection. Now, there are different types of reflections, different types of rotations, and different types of translations. And we will get into those in the following videos. But first, we need to learn just a little bit more about the terminology, okay? Because the terminology is going to be what's key to understanding how to demonstrate how a shape moved. Because I think you would agree that it would be nice if all of our math, when we were trying to move geometric shapes, was as easy as picking up a card and then moving it one way or the other. But when we're moving stuff on paper, we need to leave stuff flat. We need to be able to demonstrate this movement on a flat sheet of paper. So how do we do that? Well, we need to understand the terminology behind it. So we're going to focus strictly on where a shape starts and where it ends. Okay? Where a shape starts and where it ends. So for example, if I was going to say that this shape was going to move to my left, meaning in that direction, it would start here, and then a snapshot later, it would end here. Okay? So I would take a picture of where it started, and then I would take a picture of where it ended. And if I knew where it started and where it ended, I can categorize that this was a translation, right? A move, like a slide to the left. Okay? But it's important because if, for example, I got the snapshot of the image over here and I got the snapshot of the image here, I would think that it's also possible, if the snapshot here and here, that maybe it started here, ended here, and that maybe I can categorize this movement as a slide right. So knowing where a shape starts and where it ends helps the reader describe how it moved, or it also helps us portray a shape that is moving on a sheet of paper. Now, they have a special name for each of a starting shape and an ending shape. Now, the starting shape is called a pre-image. Okay, the type of shape where it starts is called the pre-image. Okay, it's calling it, the general shape is called a pre-image. It still is a triangle, a square, a quadrilateral, but when they label it the pre-image, this is telling you that whatever object is there, whatever shape is there, is the starting point. The ending point is called the image. Okay, the image. Where it ends is the image. Pre-image, meaning before the image. This is where it starts, this is where it ends. As a matter of fact, they use special labeling for the vertices of the object. For example, the pre-image is labeled A, B, C, or D, and it's in the corners of the object. For example, on this card, if this was my pre-image, you'll notice that the vertices of my rectangle are labeled A, B, C, and D. And if this is my starting point, they will be labeled like this. Okay? When the movement happened, whether it's a translation, rotation, or reflection, the labeling changes to let the reader know that it is a shape that has been moved. So the A, B, C, D becomes A with an apostrophe, B with an apostrophe, C with an apostrophe, and D with an apostrophe. Okay? And its labeling will look something like this. With A with an apostrophe, B with an apostrophe, C with an apostrophe, and D with an apostrophe. But they don't call it apostrophe. That's what it is. But when in math, they call this prime. Okay, the apostrophe means prime. Okay, so for example, this is A, not apostrophe, this is A prime, B prime, C prime, and D prime. Now, why does labeling the corners matter so much? Well, as you can imagine, that let's just say I'm going to grab my A corner. If I slide my A corner to the left, the A remains in the same left corner that it started out in, right? It's still there. But if you notice, if I take a different kind of movement, this A corner that I'm grabbing, and let's just say I rotate it clockwise, you'll notice it's no longer in the top left anymore. It started the labeling in the top left. Now what's in the top left is D. Okay? Or if I flip it over, you'll notice that what was A, which was in the top left, is now in the top right. Sometimes when you see a shape that is symmetrical, which means it's the same on the left and the right, it could be very confusing to say that it slid or whether it flipped. And the labeling is going to play a huge part in understanding what type of movement has happened. Now, in the following videos, we'll be looking at the different types of movement, what happens to each of these corners, the vertices, and the labeling, and it'll help us understand what type of movement happened to the various types of shapes we will be studying. That's all for today's video. I hope they help. Peace.